Jacobs. I'm Eric. I'm local, based here in New York. Lived there for 15 years, built technology at various companies. I started a company called Modal about 5 years ago. We do AI infrastructure is the best way to put it. More broadly, really compute infrastructure. So we do probably a lot of use cases in AI, data, machine learning, fair amount of computational biotech. We have customers like Suno for AI-generated music, Cognition that trains models using reinforcement learning for code generation. We have customers like Ramp, Harvey, robotics companies, many bio companies like Chai, Kyra. So we're about 120 people. We just closed the C round. We announced it yesterday, led by General Catalyst and Redpoint. Been scaling very fast. There's a lot of demand for AI infrastructure today. And so why did I start the company? By the way, with Akshat, who's a co-founder on the previous slide. Basically what I realized about 5 years ago was that today's infrastructure, and I'm really looking at the clouds, it's just not really built for AI applications, right? And so part of that was inspired by my time at Spotify. I built a music recommendation system at Spotify. This is more than 10 years ago. I ended up spending 90% of my time building the infrastructure rather than the application logic. And so, like, how do you deploy things to production? It turns out it's kind of annoying to work with existing infrastructure. You have to think about containerization. You have to think about getting the GPUs, like where do you get them? In many cases, you have to go reserve a big block of GPUs. Maybe you don't want to do that. Maybe you don't know how many GPUs you need. I have to write a bunch of YAML. It's really not good. And it really makes it slow to iterate. So one of the things I wanted to build was basically a tool I wanted to use to build complex AI applications. And we found really good inference, really good product market fit, in particular with inference. And I think a little bit like why today's infrastructure doesn't really work is like all this stuff with like GPUs and working with large models and GPU shortage and GPU capacity issues. Like this sort of made a lot of traditional infrastructure just not kind of break. It's like kind of annoying to work with. But when you're launching these models, you have like very unpredictable workloads. You need to deal with GPUs all over the world. And you need to iterate fast. So we sort of realized, what if you just like rethink all of that? What if you just like kind of build a software layer that runs on top of all the clouds? We manage all the capacity for you. Don't think about capacity. We kind of take care of it. If you need 1,000 GPUs, we'll get you 1,000 GPUs. And then it becomes our problem. But from a customer's point of view, they can do it fast. They can deploy models and not really think about the sort of infrastructure that often gets in the way of delivering value. Actually, how many people here like write software? Just curious. Okay, so like a third. How many people have like deployed models on GPUs? Okay, kind of a quarter. Okay. Just curious. So Modal, we focus on people who are building these models primarily. Like we focus on researchers. We're focusing on people who either deploys models. Now we have a new product around sandboxes. So part of it is inference, part of it is sandboxes, which basically the idea is like you have a lot of LMs that generate code today, and you want to execute that code in an isolated way. So we have a product for that as well. You also have a product for training. And so the idea is like to provide this like work with software engineers and like build a tool that they want to use to iterate with all these things. And so whether that's training or sandboxes, we have a lot of people using us for batch jobs, like scaling up things and running it on thousands of GPUs, or creating these like sandboxes for safe code execution. We have a lot of customers running millions of sandboxes at a very large scale for reinforcement learning or for background agents or for vibe coding platforms. We have a couple of vibe coding platforms like Lovable and other ones using us at a pretty large scale. I think at the sort of at a limit, like one way I end up thinking about it as like part of the product is packaging all of that in a great developer experience to make engineers and researchers iterate very fast and write code and not have to think about infrastructure. So that's a sort of developer experience. And part of what I realized, like optimizing for the developer experience is actually a really hard thing to solve. Like we ended up building our own file system very early. We ended up building our own container runtime. like we ended up having to build like a lot of like very deep sort of infrastructure in order to support this like beautiful developer experience, which today's cloud offerings don't really do well. Like it's kind of annoying to work with. I mean, actually, I love AWS. I used it for 15 years. I love it for all that it enables me to build. It just never had good developer experience, and it's very painful to work with. And so we kind of wanted to rethink. And by doing that, we had to build all these things. Like we basically threw out Kubernetes, we threw out Docker, built our own scheduler and our own container runtime and our own file system. The other way to think about Modal is we end up in the limit sort of aggregating the world's compute in a certain ways, because we run on 15 different cloud vendors today, probably more in the future, hundreds of regions. We kind of aggregate all that capacity, and the beautiful thing is that resource pooling is kind of a free lunch. If you take a lot of customers, we have a lot of customers running on many thousands of GPUs, thousands of customers. If you aggregate all those customers, even though they all have like sort of unpredictable workloads, you end up like basically the variance goes down with a sort of inverse square root, or not quite, because there's a little bit of like a skew in the distribution. But like the general idea is that the more you pull, the more smooth the sort of and more predictable the overall workloads are. And a big problem today is that GPUs are just not very highly utilized, because it's very hard to predict workloads, and it's pretty hard to manage capacity. But because we can aggregate all that demand and manage that in aggregate, we can actually drive much higher efficiency too. So part of how I think about Modal is we're sort of becoming this like very large compute demand aggregator that can sort of then go and find capacity on the other side and work with a lot of neoclouds and hyperscalers and make it easy to take our customers' code and run it in the cloud, whether that's for inference or training or sandboxes or other things. So we end up basically managing compute all over the world. I mean, this is just like one screenshot from a dashboard, but like we built this quite complex system it actually ends up being a mixed integer programming problem to like solve this bin packing problem of taking all these demand, all these tasks and place them onto Worker. We do that multiple times per minute, and manage that compute in aggregate. The objective is basically to minimize cost on our side. Customer pays a fixed fee, and ends up being quite works really well. So today, kind of going back to what I said, there's like two ways to think about Modal. One is the sort of capacity pool. We aggregate all this capacity and manage that for customers. The other way to think about it is like we make it really easy to write code and iterate very quickly. So basically supercharge developers and researchers and make it possible to build way more complex AI applications. And ultimately, that's like kind of the goal here. Is like all these companies out there building cool AI applications, they shouldn't have to think about infrastructure. So we manage that infrastructure for you. So today, a lot of Gen AI inference, video, audio. We have customers like Runway here in New York doing generative video. We have a lot of customers running big batch jobs. LM inference, of course, a very large use case for us. Forgot to put sandboxes on the slide here, but that's actually a third of our revenue, growing very fast. A lot of reinforcement learning, background tasks, vibe coding platforms, etc. So we've had this ambition of building these very sort of general purpose platform that you can use for a very large amount of different things. So almost like building kind of a new cloud, actually, but like a layer up that in a way where like developer experience better, you don't have to think about capacity. So here's just some examples of customers mentioned soon already, as well as Runway and Lovable. Many other customers. Meta is using us for reinforcement learning. Ramp also here locally. DoorDash uses us for LM inference. These are just 8 out of thousands of customers. And why do you use Modal? Typically, it's builders who want to run custom stuff with their own code. Modal is high code. We're not trying to, simplify it behind a UI. We work with software engineers who want to deploy things or scale things up. We want, people who want to iterate very quickly. A very big value prop with Modal is because we have all this, we aggregate all the capacity and the demand, and manage that very efficiently. We can charge people based on the time the compute is running. So if you're running, scale up to 1,000 GPUs, scale down to 0, you only pay with Modal for the time the GPUs are actually running, or CPUs. which is a very nice sort of value proposition. Is you don't have to think about sort of capacity planning. You don't have to go and reserve like 3 years of GPUs. You can sort of just pay as you go. It's very sort of flexible capacity model. How do you try out Modal? It's very easy. At least for software engineers, pip install Modal in your terminal. It will install it, get it, get you up and running. Typically, it takes a couple of minutes to run some Hello World and get a feel for it. Obviously, you can build very complex things. It takes a little bit longer. And that's basically it. If you want to stay in touch, I'm on Twitter, or X, I should say. Feel free to catch me. I'll be around for another hour or so. Thank you.